Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 9.6, double roots in auxiliary equations. So for this video we are gonna again, like I think chapter 4, focus on the complementary function bits and let our particular integral be 0 so that we can just focus on this point. This will cover the last solution option for the complementary function of second order differential equations. And so without further ado, let's jump right into it. Alright, so with this example, we again apply an auxiliary equation such that we get the second order just normal equation, and we need to solve for lambda, and turns out for this one it is lambda take 3 all squared equals to 0, which means that right now the only lambda option that we have is 3, full stop. Which unfortunately we do need two solutions for a second order because of the power 2. And in this case, typically in normal algebra, this will be called a double root. And so that would be the only solution that is possible. However, for differential equations, if you go through all the algebra, it wouldn't work. And the way to fix it is sort of similar to last time when we talked about the conflicting trial functions. We just need to add a coefficient of x. So our typical solution for a lambda equals 3 is a e to the 3t, because this is dot, so dx by dt, add b e to the 3t. This is if we have two 3's, but those two would be the same, which means that they cannot be separated, and so the only way to do that is to add a x in front of a b, so we get a e to 3t plus x b e to 3t, or more commonly wrote as e to the 3t times a plus b x. And if you use this as your value of x and expand into this equation, everything cancels to 0, which works. So that is basically how you deal with double roots. And for reference, double root doesn't occur often, but they might throw it into the mix, so it's better to know than not to know. And if you're cramming, which most people would be before exam, and you were watching this video, I would recommend you, if you have no clue how to do differential equations, just don't even learn this double roots, because chances are they are not gonna ask you double roots. And yeah, basically just make sure you know complementary function and trial function, the normal type, and yeah, basically cross your finger and hope. But if you're not cramming, make sure you learn this. This is easy in comparison to all the other topics that you might learn from scratch. Differential equations are very systematic, basically handle cranking work. step by step everything should follow through, and there's nothing to worry about, nothing to trip you up. Unless you have really bad algebra skills, then I don't think anyone can help you. But this aside, this would be all for this example. Let's follow through with the tips and questions. Just make a quick note, I do mean a t as coefficient in this scenario, because this is dot again. Sorry for the confusion. For the tips, I think it's important to note that if you have both a double root and a conflicting trial function, then you have some pretty annoying algebra to deal with. The trial function in that case would be x times the the normal double root solution, which means that you have an x squared e to the sum t or x, whatever. I think, yeah, actually, if you have x as your coefficient, then you have e to the something x, so that would be x squared e to the sum n x, which you can just kind of guess your way through it, but it's kind of annoying to deal with the coefficient from the first place. Also, do not mix up double root with the square root, because the square root of a value does give you one single number, but it is a plus and minus rather than two lots of a same symbol, which is 2 plus or 2 minus. In this double root, it only works if you have two of the same, whilst the square root one would give you just two different exponents. So it's something key to take note. And here we have the two questions that I have set. And as usual, I'll give you 5 seconds to pause and carry out the calculations. And I'll show you the answer in 5, 4, 3, 2, 1. And over here we have the answer. So question 1 is the tricky one, because it involves the t squared term from the particular integral. And the second one is just quite straightforward, really. So yeah, that's it for this video. I hope you've learned something. If you have any questions to do with differential equations, do let me know in the comment section below. But for now, thank you very much for watching, and I will see you on my next one.